For question 15.4, we went over this in class, but just to go over it again, basically you're giving the reactions for two different acids, nitrous acid and sulfurous acid, and their equilibrium constants. And then basically given a third reaction and asked, how can we calculate the equilibrium constant for this third reaction given the first two? And so what we need to do is look at what information do we have in the first reaction and the second reaction, and what do we need in the third reaction. And if we look in the product, we need to have 2 molecules of nitrous acid. And in this reaction, we only have 1. So as a result, we need to multiply the whole reaction by 2. And when we multiply a reaction by 2, we go on and square the equilibrium expression. And then the next thing we need to look at is in this next reaction, we have sulfurous acid as a reactant. And if we look down here in the reaction we're looking for, we have sulfurous acid as a product. So what we need to do is switch or flip this reaction. And so for the forward reaction, our equilibrium expression is products over reactants, which would be proton squared times our sulfite over our sulfurous acid, H2SO3. That's for the forward reaction, and that equals 1.1 times 10 to the minus 9. So for the reverse reaction, we'll just say Kc minus 1 to say it's reverse. If we flip this reaction, our reactants become products and vice versa. So we would have on top of the reaction now sulfurous acid over our proton squared and our sulfite. And what that does is, basically the concentration that was previously on the bottom is now on the top, and the concentrations that were on the top here are now on the bottom. So we've switched it, we've flipped it, we basically made the inverse of what we had before. So that equilibrium expression becomes now 1 over 1.1 times 10 to the minus 9, the inverse of the previous equilibrium expression that we had, simply because we flipped the direction of the reaction. And so if we multiply the first reaction by 2, got our nitrous acid, goes to 2 protons and 2 here as well. And we flip our second reaction, so we've got 2 protons plus our sulfite, and that goes to our H2SO3, our sulfurous acid. And now we want to add both those reactions together. What can we cancel out? This will cancel out, this will cancel out, and we're left with the nitrous acid, 2 molecules of nitrous acid reacting with our sulfite, giving us sulfurous acid and 2 molecules of nitrite. And so now we've got the reaction we're looking for, This equals the reaction we're looking for. And anytime we add 2 reactions together, we can find the equilibrium expression is simply the product of the equilibrium expressions for both reactions. So the equilibrium expression overall would equal the product of our first reaction, 4.5 times 10 to the minus 4 squared, times the equilibrium expression for our second reaction, the 1 over 1.1 times 10 to the minus 9. You multiply those two together, we should get an equilibrium expression, or equilibrium constant of approximately 184. And that all comes back to, if we multiply an equilibrium expression by 2, we need to square the equilibrium constant for that reaction. If we flip the direction of a reaction like we did in the second part, right? Here's the equilibrium expression for the forward reaction. Here's for the reverse reaction. We flip the reaction, we flip the equilibrium expression, so basically 1 over the equilibrium constant we had before. And then the equilibrium expression for the total reaction is the product of both of those. So we therefore just multiplied those two together to get the final equilibrium constant for this reaction of approximately 184.